Well, look at that. Incredible.
In today's video, you're going to discover why this beautiful stone showing up on your screen right now is one of the most overlooked gemstones in nature by people who don't know what it looks like in its raw state. When you look at it for the first time, all you see is a dark, dull rock with apparently no value, the kind of stone anyone would toss aside without a second thought. But when that same stone is rotated under the light, something incredible happens. Flashes of metallic blue, metallic green, intense gold, and even violet tones emerge from within the surface, creating a visual effect so striking it almost looks unreal. This stone is labradorite, and the reason so many people walk right past it is precisely this deceptive appearance when it's at rest. Labradorite doesn't shine like a diamond. It doesn't have the vibrant color of an emerald or the crystal clarity of a topaz. But what it does possess is something no other common gemstone can replicate with the same intensity: an optical phenomenon called labradorescence, which transforms a gray, opaque rock into a true display of light and color when viewed at the right angle. And the most surprising part is that this effect doesn't depend on sophisticated cutting. It's already there, hidden in the stone's internal structure, just waiting for someone to know where to look and how to recognize the right signs. So why should you care about this? Because labradorite is one of the most undervalued gemstones you can find in nature. And contrary to what many people think, it's not rare. In fact, it appears in various regions throughout the United States, Canada, and other countries, including in your region, often in publicly accessible locations, in road cuts, rocky outcrops, and even in alluvial deposits where other people only see common rocks. The difference between finding a valuable labradorite and completely ignoring it comes down only to knowing how to identify the right type of host rock, recognizing the geological signs that indicate its presence, and knowing how to test the stone in the field to confirm that you've really found something special. And here's the crucial point: gem quality labradorite, the kind that displays strong and uniform labradorescence, can sell for anywhere from $10 to $50 per carat in rough form, depending on the color intensity and the size of the piece. This means that a simple hobby of collecting stones during hikes can easily turn into a real source of extra income, especially for those who learn to recognize the right signs and know where to look. When cut into well-made cabochons with good symmetry and a polished surface that enhances the optical effect, the price can easily climb to $100 to $300 per carat. And in rare cases where the stone displays colors like intense red or orange, or complete spectral patterns, values can exceed $500 per carat. This means that a single fist-sized stone, if it has exceptional quality, can be worth hundreds or even thousands of dollars, turning a simple walk along a rocky trail into a real profit opportunity. So stick with me until the end of this video, because you're going to learn exactly what labradorite is, how it forms, what types of rock host it, how to recognize the visual signs in the field that indicate its presence, and most importantly, how to test and evaluate whether what you found actually has commercial value. And by the end, you'll understand why this is one of the most neglected gemstones by beginner hunters, but also one of the most rewarding for those who know where and how to look. Before you can go out and start looking for labradorite in nature, you need to understand what it actually is from a mineralogical standpoint. Because unlike gemstones like diamond or ruby that are defined by their chemical purity and crystal structure, labradorite is a member of a larger mineral group called plagioclase feldspar. This group includes several related minerals that form under similar conditions but have slightly different chemical compositions. Labradorite sits in the middle of this series with a composition that ranges roughly from 50 to 70% anorthite and 30 to 50% albite, two end-member minerals that mix together in various proportions depending on the temperature and pressure conditions during formation. What makes labradorite special is not just its chemistry, but the way light interacts with its internal structure. When labradorite crystallizes from molten rock deep underground, it cools slowly enough that microscopic layers of slightly different feldspar compositions form within the same crystal. These layers are incredibly thin, often just a few hundred nanometers thick, and they're stacked in alternating patterns throughout the stone. When light enters the crystal and hits these layers, it gets scattered and reflected at different wavelengths, creating the flashes of color that shift as you rotate the stone. This optical phenomenon is called labradorescence, and it's the defining feature that separates gem-quality labradorite from ordinary gray feldspar. The intensity and color range of labradorescence depend on several factors. The thickness of those internal layers controls which wavelengths of light get reinforced and which get canceled out. So stones with perfectly spaced layers show the brightest and most vivid colors. The angle at which you view the stone also matters tremendously, because the effect only appears when light hits those internal layers at the right orientation. That's why a piece of labradorite can look completely dull and lifeless from one angle. And that's also why many people walk right past it in the field. Because unless you're actively turning rocks and checking them under different lighting conditions, you'll never see what's hidden inside. Geologically, labradorite forms in igneous rocks, specifically in mafic and intermediate compositions that crystallize from magma rich in calcium, sodium, and aluminum. The most common host rocks are gabbro, basalt, anorthosite, and certain types of diorite and norite. These are all dark-colored, relatively dense rocks that form deep in the Earth's crust or in large volcanic intrusions. Anorthosite is particularly important because it's almost entirely made of plagioclase feldspar, often with very large crystals that can reach several inches across. When these massive anorthosite bodies weather and erode over millions of years, they break apart and release individual labradorite crystals into the surrounding soil, riverbeds, and gravel deposits, where they become much easier to find. One of the best-known sources of high-quality labradorite is the Labrador region of eastern Canada, which is where the stone gets its name. There, vast anorthosite intrusions outcrop at the surface, exposing layers of feldspar-rich rock that contain some of the most spectacular labradorescence ever recorded. But you don't have to travel to Canada to find labradorite. In the United States, significant occurrences are found in the Adirondack Mountains of New York, where anorthosite bodies, similar to those in Labrador, produce excellent gem-quality material. Oregon has labradorite in basaltic terrains, particularly in areas with thick lava flows that cool slowly enough to allow large feldspar crystals to grow. Parts of Arizona, California, and even areas in the Appalachian region also host labradorite, usually associated with older metamorphic terrains where igneous intrusions have been exposed by erosion. The key to finding labradorite is understanding that it doesn't occur randomly. It's tied to specific rock types in specific geologic settings. If you're walking through an area dominated by light-colored granite or quartz-rich sandstone, your chances of finding labradorite are essentially zero. But if you're in a region with dark, coarse-grained, igneous rocks, especially those with visible feldspar crystals that catch the light, then you're in the right environment. And once you start recognizing the visual cues that indicate plagioclase-rich rocks, your odds of spotting labradorite increase dramatically because you're no longer searching blindly. You're targeting the exact geological conditions where this gemstone naturally occurs. Now that you know what labradorite is and where it forms, the next step is learning how to actually recognize it when you're out in the field. Because even though labradorite can display some of the most striking optical effects in the gemstone world, in its natural state, it often looks like nothing more than a dull, grayish rock with a rough, weathered surface. That's why so many people walk right past it without a second glance. The secret is knowing what signs to look for, and more importantly, understanding that you need to actively test the rocks you find by rotating them under different lighting conditions. Because labradorescence doesn't reveal itself unless you're deliberately looking for it. The first thing to pay attention to is the color and texture of the host rock. Labradorite typically occurs in dark gray to black rocks with a medium to coarse grain size, meaning you can see individual mineral crystals with the naked eye. If you're walking through an area and you notice outcrops or boulders that are dark and dense, with visible crystals that reflect light in a dull metallic way, stop and examine them more closely. Look for flat cleavage surfaces on the feldspar crystals, because plagioclase feldspar, including labradorite, breaks along two planes that intersect at nearly 90 degrees, creating smooth, reflective faces. If you see rocks with these characteristics, especially in anorthosite, gabbro, or basalt formations, you're in prime labradorite territory. The second step is to physically handle the rocks. Pick them up, turn them in your hands, and observe how light reflects off the surface as you change the angle. Labradorescence is a directional effect, which means it only appears when light hits the internal layers at a specific orientation. If you hold a piece of labradorite flat and look straight down at it, you might see nothing but gray. But if you tilt it slowly to the left or right, or rotate it under direct sunlight or a flashlight beam, flashes of blue, green, gold, or even violet can suddenly appear across the surface. These flashes can cover the entire stone or appear in isolated patches, and they often shift and disappear as you continue rotating, which is exactly how you confirm that what you're seeing is genuine labradorescence, and not just surface reflection from moisture or mica. One practical trick used by experienced prospectors is to wet the surface of the rock before testing it. Water enhances the visibility of labradorescence by filling in tiny surface scratches and roughness, allowing light to penetrate more cleanly into the crystal structure. If you're near a stream or carrying a water bottle, splash a little water on the rock and then tilt it under the sun. If you see colors appear or intensify, that's a strong indication you found labradorite. If nothing changes, it's likely just ordinary feldspar without the right internal layering, and you can move on. Another key indicator is the size and shape of the feldspar crystals. In high-quality labradorite deposits, especially those in anorthosite bodies, individual crystals can be quite large, sometimes reaching several inches in length. These larger crystals are more likely to display strong labradorescence because they have more internal volume for those microscopic layers to develop. If you find a rock with large, blocky feldspar grains that show flat, reflective faces, and especially if those grains have a slightly pearly or metallic sheen, even when dry, take the time to test them carefully because there's a good chance you're holding gem-quality material. It's also important to know where not to waste your time. Labradorite doesn't occur in sedimentary rocks like sandstone, limestone, or shale. It doesn't appear in light-colored granites with abundant quartz and potassium feldspar, and it's rarely found in highly metamorphosed terrains where the original igneous textures have been completely destroyed. If you're in an area dominated by these rock types, your time is better spent moving to a different location where mafic igneous rocks are present. But if you're walking along a road cut, hiking trail, or riverbed where dark, coarse-grained rocks are exposed, and especially if you're in a region known for anorthosite or gabbro intrusions, then every gray rock you pass deserves at least a quick rotation test under the light. One final point worth mentioning is that labradorite often occurs alongside other interesting minerals. In anorthosite bodies, you might also find ilmenite, magnetite, garnet, and occasionally even small amounts of apatite or pyroxene. In basaltic terrains, labradorite can appear with olivine, augite, and plagioclase-rich phenocryst embedded in a finer grain matrix. These associated minerals don't guarantee the presence of gem-quality labradorite, but they do confirm that you're in the right geological environment, and they serve as additional clues that the rocks around you have the right chemistry and cooling history to produce labradorescence. Now imagine you've just found a stone that seems to have labradorescence, but you're not sure if it's really labradorite. How do you know what you're holding? After all, many gemstones look like labradorite at first glance, especially when they display metallic sheens or similar optical effects. It could be common feldspar, it could be moonstone, it could even be a variety of quartz with inclusions that create similar reflections. And here's the problem. If you don't know how to properly identify what you found, you might end up selling a valuable stone for just a few dollars. Or worse yet, throwing away something that could be worth hundreds of dollars simply because you didn't recognize its true potential. That's the difference between those who know what to look for and those who simply walk by without paying attention. And the most fascinating thing is that labradorite isn't a rare or inaccessible gemstone. It's out there in many locations, often in publicly accessible areas, just waiting for someone with the right knowledge to recognize it. But here's the issue. Most people who find an interesting stone don't know how to identify it safely, how to test its physical properties, or how to assess whether it's worth keeping, selling, or simply discarding. And it's precisely at this point that many people end up getting fooled, selling for a few dollars something that could be worth much more, or throwing away a stone that, with a bit more knowledge, would reveal its true potential. And that's exactly why I created the book Gemology Journey for Beginners, available on Amazon. This guide was developed specifically for those who are starting out and want to learn how to identify gemstones in nature, even without professional equipment. Inside, you'll find detailed explanations on how to perform hardness, density, luster, and translucency tests using everyday objects like glass, steel files, and simple scales. You'll also learn to recognize the visual patterns that differentiate a real gem from a cheap imitation, and most importantly, how to avoid being fooled by opportunistic buyers who take advantage of beginners who don't know what they're holding. With this knowledge, you gain confidence to evaluate your own discoveries, decide what's worth keeping or selling, and build a collection or even turn this into a source of extra income. But if now isn't the right time for you to get the book, no problem. You can still keep learning here on the channel completely free. Just subscribe, like this video, and watch the next episode showing up on your screen right now. Each video was designed to help you see what others overlook, and who knows, maybe find your own discovery someday. Thanks for liking and subscribing. Good luck, Gem Hunter.